We'll start with another chapter of integration called as integration by partial fractions. How do I identify it? It will be in the form integral of dx upon quadratic. Question: if it is dx upon quadratic, why don't I do it directly by the quadratic method? In this case, it is not possible to find the factors of quadratic, right? It is not possible to find these factors. It is possible to find the factors. When we are doing quadratic, my mistake guys. When you are doing quadratic, it is integral of 1 upon quadratic where it is not possible to find the factors. Hence, we use the formula last term formula, middle term into middle term upon 4 times first term. Here, it is integral of dx upon quadratic wherein it is possible to find the factors of quadratic. So when it is integral of dx upon quadratic where it is possible to find the factors of quadratic, then it is called as partial fraction, right? Let's see how do we do the sum. Integral of 3x minus 2 upon x square minus 3x plus 2 dx. Right? Now, let's see this. I can say I is equal to integral of 3x minus 2 quadratic. Factors of 2 are 2 and 1, minus 2 minus 1 gives you minus 3. So the factors will be x minus 2, x minus 1. I can find the factors. Right? Once you've done this, you will say let 3x minus 2 upon x minus 2, x minus 1 be equal to a upon the first denominator plus b upon the second denominator. Right? So therefore I can say 3x minus 2 upon x minus 2, x minus 1 is a into x minus 1 plus b into x minus 2 upon x minus 2, x minus 1 LCM. Right? So cancel, 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 cancel. Now comes the interesting part guys. Let's have a look at this. X minus 1 plus b into x minus 2. I want to make this bracket as 0. If I want to make this bracket as 0, what should I assume the value of x? I should assume the value of x as 1. If I assume the value of x as 1, 1 minus 1 will give you 0. So let us assume that the value of x is 1. In that case, my equation will be 3 into 1 is 3 minus 2. 1 minus 1, 0. So I need not write that. B into 1 minus 2. So I'll get 1 is equal to minus b, b is equal to minus 1. Right? Let's see another thing. Now I want to make the second bracket as 0. If I want to make that bracket as 0, what should I assume the value of x? I'll assume the value of x to be 2. 2 minus 2 is 0. So in that case, this will be 3 2s are 6 minus 2 is a into 2 minus 1. So 4 is equal to a. So thus I get the value of a and b. Now I can say that I is integral of this 3x upon x minus 2, x minus 1, which we have assumed is a upon x minus 2 plus b upon x minus 1. A is 4 upon x minus 2 plus b is minus 1 upon x minus 1 dx. This can be written as 4 integral of 1 upon x minus 2 dx minus integral of 1 upon x minus 1 dx. 4 integral of 1 upon ax plus b is 1 upon a log mod ax plus b. So the value of a is 1 here. Straight away log x minus 2 minus log x minus 1 plus c. Sum is over. Right? Let's move on to the next sum guys. Integral of 2x square minus 1 upon x square plus 4 x square minus 5 dx. Now, here you get, they've already given it to you in terms of factors, so you will straight away say let 2x square minus 1 upon x square plus 4 into x square minus 5 be equal to a upon x square plus 4 plus b upon x square minus 5. LCM 2x square minus 1 a x square minus 5 plus b x square plus 4, common denominator gets cancelled. I need to make the first bracket as 0, so I'll assume x square to be 5. If I want to make this as 0, I'll assume the value of x square to be 5. So this will be 5 2s are 10 minus 1. This term becomes 0. B, this is going to be 5 plus 4. So 9 is equal to 9b. So in that case, b is equal to 1. Let us assume, in order to make the second bracket as 0, let us assume the value of x square to be minus 4. Right? So in that case, I will have 2 into minus 4, that's minus 8 minus 1 is a minus 4 minus 5. So in that case, you will get minus 9 is equal to minus 9a. So a is equal to 1. I can say I is, let's copy the sum, 2x square minus 1 upon x square plus 4 into x square minus 5 dx. This can be written as a. A is 1 upon x square plus 4 plus b. B is 1 upon x square minus 5 dx. This can be written as integral of, flip the integral sign, x square plus 2 square dx plus integral of 1 upon x square minus root 5 the whole square dx. Integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a. Integral of 1 upon x square minus a square, 1 upon 2a log mod x minus a upon x plus a plus c. The value of a here is root 5. So your final answer is going to be 1 upon 2 tan inverse of x by 2 plus same formula, 1 upon 2 root 5, same thing here is going to be log mod x minus root 5 upon x plus root 5 plus c. Right? Let's move on to the next sum, guys. Integral of x minus x square upon x square minus 2x minus 3 dx. The degree of polynomial is same in the numerator and denominator. When the degree of polynomial is same in the numerator and denominator, you have to introduce the denominator in the numerator. First, I write the denominator as it is. Introduce the denominator in the numerator. So write the denominator as it is in the numerator. Introduce the denominator in the numerator. What did I actually have in the numerator? Minus x square. In order to get minus x square, I put a minus sign outside. So that will give me minus x square. I have plus x and I have plus 2x. In order to get plus x, I will subtract x, because see this, minus into minus plus 2x minus x will give me plus x. I have a plus 3 extra. To get rid of it, I will write minus 3 dx. Remember guys, we did this in polynomial type, introducing the denominator in the numerator. This can be written as split the numerator, x square minus 2x minus 3 upon x square minus 2x minus 3 dx plus integral of minus x minus 3 upon x square minus 2x minus 3 dx. Right? Minus sign goes out, cancels in the numerator denominator, integral of dx. Between these two terms I could take minus sign common, integral of x plus 3. Now 3 factors of 3 are 3 and 1, and minus 3 plus 1 will give you minus 2. Minus 3 plus 1, I'm solving the quadratic, right? Leave that there as it is. You will say that let x plus 3 upon x minus 3 into x plus 1 be equal to a upon x minus 3 plus b upon x plus 1. Therefore, you could say that x plus 3 is a times x plus 1 plus b times x minus 3, common denominator getting cancelled. To make the first bracket as 0, you will say let x be equal to 1. If x is let x be equal to minus 1. So if x is minus 1 plus 3 is b minus 1 minus 3. So in which case I'll get 2 is minus 4b. So b is minus 1 upon 2. Now to assume the second bracket as, or to make the second bracket as 0, I'll assume the value of x to be 3. So I'll get 3 plus 3 is a times 3 plus 1. 6 is equal to 4a. 3 upon 2 is equal to a. Let's get back to my original form. I can say I is minus integral of dx minus integral of x plus 3 upon x minus 3 into x plus 1 can be written as a. A is nothing but 3 upon 2. A upon x minus 3 plus b. B is minus 1 upon 2 x plus 1 dx. Remember we had assumed this here. A upon x minus 3, a upon x minus 3 plus b upon x plus 1, right? And then I substituted the value of a and b. Now this can be written as minus integral of dx minus minus constant outside 3 upon 2 integral of 1 upon x minus 3 minus into plus minus into minus plus 1 upon 2 integral of 1 upon x plus 1 dx. Right? Minus integral of dx is x minus 3 upon 2 log mod x minus 3 plus 1 upon 2 log mod x plus 1 plus c. That will be your answer. Let's move on to the next one, guys. Integral of x plus 2 upon x cube minus x dx. Let's see this. I is equal to integral of x plus 2. I could take x common in the denominator, so I'll get x square minus 1 dx. This can be written as integral of x plus 2 upon x. X square minus 1 is in the form a square minus b square, which is nothing but a plus b, a minus b dx. Let us assume that x plus 2 upon x, x plus 1, x minus 1 is a upon x, a upon the first denominator, b upon the second denominator, c upon the third denominator. Right? Take LCM, so you will get x plus 2 is a times x plus 1 into x minus 1 plus b times x into x minus 1 plus c times x into x plus 1. Right? I have taken LCM here. I have cancelled out the common denominator. Now you had three denominators. One at a time, try to make each denominator 0. Let's assume I want to make this bracket as 0. So I'll assume the value of x to be minus 1. In order to make this bracket as 0, I'll assume the value of x to be minus 1. So I'll get minus 1 plus 2. X plus 1, that means this term will become 0. B, x is minus 1, minus 1, minus 1. X plus 1, minus 1 plus 1, 0. So C term will also become 0. So I'll get 1 is B minus 2 into minus 1 plus 2. So B is equal to 1 upon 2. Next, I already made this bracket as 0. Now I want to make the second bracket as 0. So I'll say let x be equal to 1. Right? So in that case I'll get 1 plus 2. If x is 1, this bracket will be 0, therefore this term will be 0. If x is 1, this bracket will be 0, therefore this term will also be 0. So I'll get C 1, 1 plus 1. So I'll get 3 is equal to 2C, C is equal to 3 upon 2. Now I need to make the third term as 0. I want to make this term as 0. X is all by itself, so I'll assume the value of x to be 0. If I assume x to be 0, I'll get 0 plus 2 is a into 0 plus 1, 0 minus 1. Since there is x here, this term will become 0. Since there is x here, that term will also become 0. So I'll get 2 is minus a is minus 2. Now substitute. I can say I is integral of, use your partial fraction a upon x, so minus 2 upon x plus b, that's 1 upon 2, b upon x plus 1 plus c upon x minus 1. I am substituting the value of a, b and c. Split the integral sign, bring the constant out. Minus 2 integral of 1 upon x dx plus 1 upon 2 integral of 1 upon x plus 1 dx plus 3 upon 2 integral of 1 upon x minus 1 dx. Minus 2. Integral of 1 upon x is log mod x plus 1 upon 2. Integral of x plus 1 is log mod x plus 1 plus 3 upon 2. Integral of 1 upon x minus 1 log mod x minus 1 plus c. Next sum. Integral of x square upon x square plus 1, x square minus 2, x square minus 3 dx. Straight away they have given you the factors, so you will say let x square upon x square plus 1, x square minus 2, x square minus 3. I'll just recheck whether I copied the sum correctly. No, it's plus 3. X square plus 3 plus minus plus. Okay, yeah. Let's move on. This is a upon the first denominator plus b upon the second denominator plus c upon the third denominator. Right? LCM straightforward. X square is equal to a times x square minus 2 x square plus 3 plus b times x square plus 1 x square plus 3 plus c times x square plus 1 x square minus 2. Fine? Do we get this? Therefore, I can common denominator cancel. Now, I want to make this bracket as 0. You will say let x square be equal to 2. So in that case 2 x square minus 2, therefore this term becomes 0. B 2 plus 1 2 plus 3 x square minus 2. So the third term also becomes 0. So 2 is equal to 3 and this is 5. 15b 5 3s are 15. So b is equal to 2 upon 15. Let's make the second bracket as 0. Let x square, I want to make this bracket as 0, be equal to minus 3. So you will get minus 3 x square plus 3. Therefore this term becomes 0. X square plus 3. Therefore this term becomes 0. The last term c. This is minus 3 plus 1 minus 3 minus 2. Minus 3. This is minus 2 minus 5. 10. Minus 3 upon 10 is c. Let's make the third bracket as 0. Let here the third bracket x square plus 1. So I'll assume x square to be minus 1. If I assume x square to be minus 1, I'll get minus 1 is a minus 1 minus 2 minus 1 plus 3. X square plus 1, this term becomes 0. X square plus 1, this term becomes 0. Minus 1, this is going to be minus 3 and plus 2. Minus 3 plus 2, minus 6a. So a is equal to 1 upon 6. Start with the sum. I is equal to integral of a upon x square plus 1 dx plus b. B is 2 upon 50. B upon x square minus 2 dx plus integral of c. C can be written as minus 3 upon 10 x square plus 3 dx. Get the constants out. I've already split the integral sign. This is 1 upon 6 integral of 1 upon x square plus 1 dx plus 2 upon 15 integral of 1 upon x square minus root 2 square dx plus into minus 3 upon 10 integral of 1 upon x square plus root 3 the whole square dx. This can be written as 1 upon 6 integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a plus 2 by 15 integral of 1 upon x square minus a square 1 upon 2a log mod x minus a upon x plus a minus 3 upon 10 integral of 1 upon x square plus a square 1 upon 2a log mod a plus x upon a minus x plus c. This can be written as 1 upon 6 tan inverse of x. 2 and 2 gets cancelled, so this is plus 1 upon 15 root 2 log mod x minus root 2 upon x plus root 2. This is root 3 and 3 will get cancelled, so you will get root 3 upon 20 log mod root 3 plus x upon root 3 minus x plus c. That will be your answer. On the next slide. Some mistake here, guys. Integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a. I've used that formula, same formula here. Only the last term is changed here. 1 upon x square plus a square, 1 upon tan inverse of x square plus a square. Integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a. So this is going to be 1 upon a tan inverse of x by a plus c. So this is going to be root 3 by 10 tan inverse of x by root 3 c. right? That formula was for a square minus x square. I read it wrong. So let's move on to the next sum, guys. Integral of sec square x upon 1 plus tan x 3 plus 2 tan x dx. Let tan x be equal to t. Differentiate with respect to x. D by dx of tan x is sec square x is dt by dx. Therefore, dx is dt upon sec square x. I can say I is integral of sec square x upon 1 plus t 3 plus 2t dt upon sec square x, right? This can be written as integral of dt upon t plus 1 2t plus 3 sec square x gets cancelled. You will say let 1 upon t plus 1 into 2t plus 3 be equal to partial fractions 1 upon a upon t plus 1 plus b upon 2t plus 3. LCM 1 is equal to a into 2t plus 3 plus b into t plus 1, right? Let t be equal to, I want to make this bracket as 0, so I'll assume t to be equal to minus 3 by 2, 2 and 2 will get cancelled, plus 3 minus 3. So in that case I'll get 1 is equal to b minus 3 by 2 plus 1. So 1 minus 3 plus 2 minus 1 by 2 b, therefore b is minus 2, right? I want to make the second bracket as 0, so I'll say let t be equal to minus 1. 1 is equal to a 2 plus 3, 1 upon 5 is equal to a, right? I can say I is integral of a is 1 upon 5 t plus 1 plus b is minus 2 upon 2t plus 3 dt. Split the integral sign, 1 upon 5 integral of 1 upon t plus 1 dt minus 2 integral of 1 upon 2t plus 3 dt. This is 1 upon 5 log mod t plus 1 minus 2 into 1 upon 2 log mod 2t plus 3 plus c. Resubstitute the value of t, 1 upon 5 log mod tan x plus 1 minus log mod 2 tan x plus 3 plus c. Right? Next, let's move on to the next sum, guys. Integral of cos x upon 1 plus sin x 2 plus sin x 3 plus sin x dx, right? Let us assume let sin x be equal to t. Differentiate with respect to x. So in that case d by dx of sin x is cos x is dt by dx. So dx is dt upon cos x. I is integral of cos x upon 1 plus t 2 plus t 3 plus t dt upon cos x, right? integral of 1 upon t plus 1, t plus 2, t plus 3 dt. Partial fractions, let 1 upon t plus 1, t plus 2, t plus 3 be equal to a upon t plus 1 plus b upon t plus 2 plus c upon t plus 3. This is 1 is equal to a times t plus 2 t plus 3 plus b times t plus 1 t plus 3 plus c times t plus 1 t plus 2. Right? Now, common denominator I have cancelled. Let t be equal to, in order to make the first bracket as 0, I'll assume t to be minus 2. So t plus 2, this term becomes 0. b minus 2 plus 1 minus 2 plus 3 1 b minus 1 plus 1. So b is equal to minus 1. Next, let t be equal to t plus 3, so minus 3. To make that bracket as 0, I'm going to assume the value of t to be minus 3. 1. It has a t plus 3, this term becomes 0. t plus 3, this term becomes 0. This is minus 3 plus 1, minus 3 plus 2. So this is minus 2 minus 1. So 2. So 1 upon 2 is equal to c. Next, let t be equal to third term, minus 1. So 1 is equal to a times minus 1 plus 2 minus 1 plus 3, t plus 1 0, t plus 1 0. So in that case I get 1 is equal to a 1 and 2. So I will get a is equal to 1 upon 2. Now I can say I is equal to integral of 1 upon a. A is 1 upon 2 t plus 1 plus b. B is minus 1 upon t plus 2 plus c is 1 upon 2 t plus 3 dt. This is 1 upon 2 integral of 1 upon t plus 1 dt minus integral of 1 upon t plus 2 dt plus 1 upon 2 integral of 1 upon t plus 3 dt. So this can be written as 1 upon 2 log mod t plus 1 minus log mod t plus 2 plus 1 upon 2 log mod t plus 3 plus c. We substitute the value of t. So 1 upon 2 log mod t. T is nothing but sin x. Sin x plus 1 minus log mod sin x plus 2 plus 1 upon 2 log mod sin x plus 3 plus c, right? Next, let's see the next sum. Integral of x cube minus 4x square plus 3x plus 11 upon x square minus 5x minus 6 dx. Last sum to finish this type. Now, here the degree of polynomial in the numerator is greater than that of the denominator. Since the degree of polynomial in the numerator is greater than that of the denominator, you divide the numerator by the denominator. X cube minus 4x square plus 3x plus 11. Right? Now what should I multiply x square with? In order to get x cube, I should multiply it with x. So this is going to be x cube minus 5x square minus 6x. So this is going to give you, subtract all the signs reverse. So this is going to give you x square. I presume that the sum is being printed wrong in the textbook. This should be plus 6. I guessed as much. So this is plus, so this is minus. The sum was printed wrong. The denominator should be x square minus 5x plus 6. So now this is going to be x square. This is minus 6x plus 3x is minus 3x plus 11. I should multiply, what should I multiply x square with in order to get x square plus 1? So this is x square minus 5x plus 6. All the signs reverse. So in that case you will get this as 2x plus 5. Now I can write I. This is my numerator. The same term I have written here. Divisor is equal to dividend into quotient plus remainder. So instead of writing the divisor, I will write dividend into quotient plus remainder. Divisor is equal to dividend into quotient plus remainder upon x square minus 5x plus 6 dx. Split the numerator, x square minus 5x plus 6 into x plus 1 upon x square minus 5x plus 6 dx plus integral of 2x plus 5 upon x square minus 5x plus 6 dx. This can be written as integral of x plus 1 dx plus integral of 2x plus 5. Factors of 6 are 3 and 2. X minus 3, x minus 2 dx. Right? Now let's leave that there for the timing. Let us assume that 2x plus 5 upon x minus 3, x minus 2 is a upon x minus 3 plus b upon x minus 2. So 2x plus 5 is a into x minus 2 plus b into x minus 3. In order to make this bracket as 0, I'll say let x be equal to 2. So I'll get 4 plus 5 is b, 2 minus 3. 9 is equal to minus b. So b is equal to minus 9. In order to make this bracket as 0, I'll say let x be equal to 3. So 6 plus 5 is 3 minus 2. 11 is equal to 8. So I can now say I is integral of x plus 1. I can split the integral sign. X dx plus integral of dx plus this 2x plus 5 upon x minus 3 into x minus 2 can be split as 11 upon x minus 3 plus minus 9 upon x minus 2 dx. This can be written as integral of x dx plus integral of dx plus 11 integral of 1 upon x minus 3 dx minus 9 integral of 1 upon x minus 2 dx. This is nothing but x square by 2 plus integral of dx is x plus 11 log mod x minus 3 minus 9 log mod x minus 2 plus c. This finishes partial fractions part 1, where you do not have repeated factors in the denominator. In partial fractions part 2, we will see denominators where you have repeated factors. For the timing, this finishes this chapter, part 1 of partial fractions. Thank you very much.